Okay, I'm just going to change the cents to rands, and I'm going to do that by saying 1,642. Hello, mathematical literacy learners. Welcome to question 2. Every time I start, the background noise. Eastern Cape, September 2021. So let's just get started. The Fisher family consists of the wife, husband, and son. Plans to spend the festive season with friends and in Gqeberha, which is also known as Port Elizabeth, and then proceed to Johannesburg. So they're going to go from Cape Town to Port Elizabeth to Johannesburg. Now the family will be traveling by car from Cape Town to Port Elizabeth. And then the family intends to take a 60-minute break at Mossel Bay. They will depart from Cape Town on a Friday at 8 a.m. and plan to arrive in Port Elizabeth at 5:30. So from Cape Town to PE, they're going to take this long. Now remember, they're taking a car from Cape Town to PE, so it's going to take them this long. And then also, this duration of time here from 8 to 5:30, it includes the break time. So you cannot use that time to calculate the speed. You would have to minus the time that they were not driving first before you use that time to calculate the speed. Write down the names. Wait, let's start here first. Map for 2.1. Here we go. So we have a map here with a scale, and I already went ahead and did my measurements there for my bar scale. So we have a bar scale, we have north, and if you measure the whole thing, you'll get 32 millimeters or 3,2 centimeters for 300 miles. It says miles there. And then for 23 or 2,3 centimeters, 23 millimeters, you get 300 kilometers in real life. So this measurement is for the plan, and that one is for real life, and you have your scale. Now the lovely thing about a bar scale is you can use it like this. Now another question that you can get before we continue, you get a question where they say change the bar scale to a ratio scale. First, write it as it is, like 23 millimeters is equal to 300 kilometers. Then change kilometers to millimeters, and then divide 23 by 23, and then you get 1:2, and then you get your scale as a ratio scale. Okay, but we are not going to do that because it's not asked. Okay, so now write down the names of 2 towns they will pass through on their trip to Port Elizabeth. Now, if you look at here, from Cape Town to Port Elizabeth using the N2, they pass Mossel Bay, they also pass through George, and they pass through this KNYSNA town. So the question said only write 2. That means you don't have to worry about writing all 3, because I can't read that one properly. I can't pronounce it either. So I'm just going to write George and Mossel Bay. So 2.1.2 says, give the general directions used when traveling from Cape Town to Johannesburg via Port Elizabeth. Now, what is the general direction? It is the campus direction. Now, we are traveling in 2 destinations. First, we're traveling from Cape Town to PE. We're going to Johannesburg, yes, but first we go to PE. Then we go to Johannesburg. So here is Cape Town, here is PE, and there is Johannesburg. So we're going to go from there to there, and from there to there, right? So we're going to say, let's use our north. There's our north over there. So north is up, according to that, over there. So if we go from Cape Town is on the east. This looks more like just east to me. I wouldn't say northeast or southeast. This is east. So the first direction is east. So this one is when you're traveling from Cape Town to what's this place? PE, right? Gqeberha. And then you have 2.1. We're not done. Then we travel from PE to Johannesburg. It's north, but then it's northeast. So this one is northeast, will be from PE to Johannesburg. And then we move on to 2.1.3. Now, 2.1.3 says, state 2 advantages of using national roads. Well, that's nice. National roads is you drive as fast as possible. Well, the speed on the national roads is higher than on other roads. The limit of the speed on national roads is higher, so you can drive faster. There's less obstacles like robots. What do you call robots? Robots are not technically called robots. Okay, robots. You correct me there with the right term. So you don't have to worry about obstacles such as robots and speed humps and people crossing the road, right? So you'll travel faster. And what else? And when you drive on the freeway, of course, and you don't have any obstacles and you're driving faster, you save on petrol, right? And then another one would be you can drive on most of these. You can drive on the national road from one town to the next, without having to use regional roads. I mean, you can pass through a town, but other than that, just passing through, and then you get back to your national road. So that's nice, right? Okay, so we're going to move on to the next one. 2.1.4, use Annexure A to calculate the actual distance between Cape Town and Port Elizabeth Shore. All calculations give your answer to the nearest kilometer. First, I'm just going to check if we are given the kilometers. We're not given the kilometers, so we first have to go and measure the distance from Cape Town, to Port Elizabeth. So I'm just going to take my ruler, and I remember I use this side because it clearly shows. I like to put it on the center of the town to the center of the town. So I'm going to go with 71 millimeters or 7.1 centimeters. So I'm going to say 7.1 centimeters or 71 millimeters for me. Okay, now let's see. So my distance on the map is equal to 7.1 centimeters. I like centimeters when I'm using a scale. And then I'm going to change this. So this one is on the map. Now I'm going to put it on the real life. As they said there, they want to know the actual distance. The one we have right now in centimeters is the one from the plan. So what does the scale say? Let's go back there. We measured the scale and we said it's 23 millimeters equals to 300 kilometers. So let's go there. 2.3 millimeters is equal to 300 kilometers, right? And then we have the measurement of the plane, which is 7.1 centimeters, and I do not know what it is in real life. I'm just going to cross multiply. Then I say 2.3 centimeters. Centimeters is equal to, no, why am I making so many mistakes? 2.3 centimeters multiplied by unknown is equal to 7.1 centimeters times 300 kilometers. And then I say divide by 2.3 centimeters this side, divide by 2.3 centimeters this side, and I get my answer using a calculator. 7.1 times 300 divided by 2.3, and I get 926,086,9565 kilometers. Remember, it's in kilometers here, and then it's going to give us kilometers. Bar scale is like that. They said round off. Now let's go back to the question. Calculate the actual distance. We did that. Give your answer to the nearest kilometer. So they don't want anything to do with the comma. So we're going to say 926. How do I do that? I looked at 6 here, which is going to be the last number. And I looked at the neighbor and I said, what does the neighbor say? It says 6 must stay the same. It's less than 5. Therefore, it's 926 kilometers. Next. 2.1.5 says the Fisher family is traveling at an average speed of 100 kilometers per hour. Prove by means of calculations whether they will be able to reach Port Elizabeth at the planned time. The following formula may be used. Startled me. The Fisher family is traveling at an average speed of 100 kilometers per hour. Now, prove by means of calculations whether they will be able to reach Port Elizabeth at the planned time. Okay, now we have the speed, we have the duration. Let's check if the time that they are traveling at the speed that they're traveling, right? The time that they're traveling at the speed that they're traveling will give us the distance they need to travel. We said that they need to travel 926 kilometers. Let's go back to what we have. We have here. Here we have the time they started till the time they arrived in Port Elizabeth, and then we have the break time. So I'm just going to go ahead and sort out the time taken. So in order to calculate the time taken, I need to first check how long did they take. So I'm just going to copy everything down. So they this is 2.1.5. They departed at 8:00, and then they arrive at 17:30. Their break is 60 minutes. Right. Okay, so I'm just going to calculate the duration of the driving time first. They drove, they arrived at 7:30 minus the starting time, finish minus starting, and that's going to give us 0.3. And that one we borrow, what am I doing? We borrow 1 from there, and that's 0, and then we bring it here. This is 17 minus 8. Before I make more mistakes, it is 9. So at 9 hours and 30 minutes. Now, they are not driving for 9 hours and 30 minutes because 1 hour, the 60 minutes, they are doing what? They are they're braking. So we have to minus the 60 minutes. So 0 minus 0. 0. Now we can't minus 6 from 3. So I'm just going to go and borrow there, and we're going to left with 8, and then it's going to become 60 minutes. So 6 plus 3 is 9. 9 minus 6 is 3. So we have 30 minutes there. 8 hours and 30 minutes. So they're traveling for 8 hours and 30 minutes. Now, here's the thing. To calculate speed, I have to convert that to ndoni to hours as well. So here we have 8. Let me just move my stuff. We have 8 hours and 30 minutes. Then we can then say 8 hours and 30 minutes. Then we say converting 8 hours. So now let's convert 8 hours and 30 minutes. So and 30 divided by 60, that is 0.5. So this one is going to be 8.5 hours. Now let me just do it here. 8 hours plus 0.5, and then you get 8 hours and 8.5 hours, right? Okay, now let's calculate using the thingy, the what you call this thing, the formula. Okay, now let's see if we use speed and time, will we get 926? Okay, so for distance is equal to speed times time. And then we have distance that we want to be calculating is equal to speed, which is 100 kilometers per hour times time. And then we have time we said it's 8.5 hours. And then we say what is this? 100 times 8.5, and that is equal to 850 kilometers. So if they drive for 100 if they drive at 100 kilometers per hour with this time, they're going to get a distance of 950. Now they're not going to finish in time, right? So this time, so the statement is not true. 926 kilometers minus 850 kilometers, they are going to still have to travel for 926 kilometers. 926 minus 850, they still have to travel 76 kilometers, which is still going to take much longer. So 100 kilometers is not going to cover it at this time. This time and this speed is not going to make it, right? So they will arrive late. They will arrive after 17:30 because they'll still take longer. Now this is when you prove distance. You find the distance that this time that we are given is going to do. Or what we can do, so I'm going to do this a second option. So second option is I will then say I'm going to check if I can get if the 100 kilometers is the speed they will actually be driving at. So I have distance is equal to speed times time. I have all these, so I can check anyone. So if I use distance and time, I'm gonna verify my speed here and see if it is actually enough to arrive on time. Okay, so 926 kilometers is equal to speed times the time. We said the time is 8.5 hours. 8.5 hours, right? So 8.5 hours. And then we want speed, so we're going to say, I'm just going to do the step here. 926 is equal to speed times 8.5. We want speed, so we're going to divide by 8.5 this side and divide by 8.5 this side. And that will be 926 divided by 8.5. That's going to be 108.941 kilometers per hour. So they have to drive an average of 109 kilometers per hour in order to make it in time. Okay, I'm excited. Now I'm going to prove the other one. I'm going to prove the third one. I'm going to use speed and distance and check if the time they need to drive. We calculated the time. Now I'm going to check my speed if I get it. So we checked the speed, distance. We checked the speed. Now we're going to check time. Okay, let's check time. Distance is equal to speed times time. And then we have distance, right? So we have distance, which is 926 kilometers, is equal to a speed of 100 kilometers per hour times our time. So this time I'm going to divide by 100 and divide by 100. Yeah, I said 1,000. Okay, so that will be 926 divided by 100. 926 divided by 100 is 9.26 hours. So that would be 9.26 hours, which is equal to time. Now we're going to check at what time will they arrive. Okay, so here we're going to say 9 0.26 hours is 9 plus 9 hours full plus 0.26 hours. And then we're going to multiply this by 60. Then we're going to get 9 hours. 9 hours. We're going at 0.26 times 60, and that is 15. So we're going to say 9 hours and 15.6 minutes. So we can convert it to 16 minutes, but it's fine. I'm going to use it like this. So we have 9 hours and 15.6 minutes. Very good. And then what we're going to do now is check. They started at, let's go back. I forgot what time they started at 8 o'clock in the morning. So they start at 8:00 plus 9 hours and 15 minutes. So I'm going to say 15.6. I'm just going to note the 0.6, whatever. And then I'm going to say 0 plus 5 is 5. And 0 plus 1 is 1. And 8 plus 9. 8 plus 9 is 17. So that is 17:15. 17:15, remember, the 17:15 is the time for driving. They still break for 60 minutes. So that's 5, 7, and ... 71. Okay, now we don't write that. 75 minus 60, that's 15. Okay, 1, 5, and 1, 5, and what happens to the 60 minutes? It goes this side, the hour, and that becomes 18. So they will arrive at 18:15 and some seconds. Right, so 18:16 if you round off. So yeah, those are the 3 ways. So they'll arrive later than whichever way you do it, they will arrive later than the 5:30 that's mentioned there. The price of petrol is 1,642 cents per liter. Mr. Fisher drives a Jeep Wrangler with a fuel capacity of 75 liters. The Jeep has a fuel consumption of 7.6 liters per 100 kilometers. Okay, let's look at it. We have a price of petrol there in cents. Never. We don't use cents. We use rands, then cents. Okay, Mr. Fisher drives a Jeep Wrangler. Nice for him. With a fuel capacity of 75 liters. It takes capacity, remember, is the capability of the tank here, right? So what the tank is capable to take, 75 liters. And the Jeep, so 75 times this money will be the cost of the petrol tank. The Jeep has a fuel consumption of 7.6 liters per 100 kilometer. So when he travels 100 kilometers, he uses 7.6 liters. Now 2.2.1, calculate the amount of petrol that will be used for a return trip to Port Elizabeth. Now they want to know how much is the petrol going to cost if he goes to Port Elizabeth and then back. We need the distance. What was the distance? 90. Let's go find the distance. 926. Let's just remember what the distance was. The distance was 926 kilometers. Very good. And then we're just going to say, for this, they're going to a return trip. They're going to, so that's going to be plus 926 kilometers. So what you can do is calculate for 926 times 2, or you can just add them together and then calculate together. Well, he's traveling 926 kilometers from Cape Town 2, and then that's from Cape Town 2, and then another 926 going backwards. So they're going to travel a total of 926 plus 926, 1,852 kilometers. Okay, now that we know the total traveling distance, let's find out how much petrol are they going to need. Now, let's go to the consumption. They're going to need 7.6 kiloliters is traveled, takes, okay, 100 kilometers takes 7.6. And then I'm going to say, but I have 1,852 kilometers and I don't know. So what I'm going to do is I'm going to say 7.6 times 1,852 is equal to unknown times 100. And then I'm going to say divide by 100 this side, divide by 100 this side, as usual. 7.6 times 1,852 divided by 100. That should give me 140. $140.752 liters. Those are my liters. And then 2.2.2, I'm going to go ahead and say, what is the question there? Determine the petrol cost for the return trip in rands from Cape Town to Port Elizabeth. We have the cost there for petrol right there, 1,642 cents per liter. 1 liter is equal to 1,462 cents. Just going to check. I make a lot of mistakes. It's 1,600. Yeah, there we go. 1,642 cents. There we go, 1,642 cents. Okay, I'm just going to change the cents to rands, and I'm going to do that by saying 1,642 divided by 100. They did say my answer must be in rands, so I'm going to do that first. Is equal to 16.42. Then now that I have my 16.42, I am going to say is equal to, and we have how many liters? 140 right there, 140.752, and we don't know how much it is, and we're just gonna do that. So 16.42 times 140.752 is equal to 2311.14 784, and this is money, so it has two numbers on the other side of the comma. 2311.15, and we're good. Question 2 is done. Come back for question 3.